Today we are going to do an introduction of Newton's law of cooling through math equations. We'll start with question 4. A hot cup of coffee loses heat in a colder environment according to Newton's law of cooling. dt over dt is equal to minus k times by T minus Te, where T is the temperature of the coffee in degrees Celsius at the time T, and Te is the temperature of the environment, and k is a positive constant. For A, show that T is equal to Te plus Ae to the power of minus kt is the solution of this equation for any constant A. So to do this, we're going to take our two equations. We're going to say T is equal to Te plus Ae minus kt, and also minus k and minus k times by T minus Te. That's our second equation. And dt over dt. Oh, that should be capital. It's equal to minus k. So for this equation here, we're going to start by using the first derivative. So always say using first derivative. So when deriving dt by t, we know that we take the constant, the coefficient of t, and move it in front of here, and then for constant terms such as Te, we just get rid of them. So it's just going to give us minus k Ae to the power of minus kt, and for this one here, we're just going to expand the brackets, so it's going to be minus k times by t. But what is t? T is this value here, Te plus Ae. So it's going to be minus kte minus kae to the minus kt, and then it's just going to be plus kte, which is just that and that term there. And I'll make my writing a bit nice. I need a kte, and then that's just gonna, those two terms are just gonna cancel, and it's just gonna give us minus kae to the minus kt, which is equal to this term, these two terms here. So therefore QED, double tick. For B, right, I make myself a cup of coffee and find that it is already cooled from boiling point to 90 degrees Celsius. The temperature of the air in the coffee is 20 degrees. What are the values of Te and A? Well, first of all, Te, it says that Te is the temperature of the environment, and hence Te must be 20 because 20 is the temperature of the air in the office, which is the temperature in the environment. So we're just going to write Te is equal to 20 degrees Celsius. And now for A, we are going to set T equal to 0. So we're going to have, the lowercase t is equal to 0. So what we're going to have is 90, which is the original temperature of the coffee, is equal to 20 plus Ae minus kt. Now since we're making the lowercase t here 0, it's going to equal to 20 plus Ae to the 0. This is just 1. Anything to the power of 0 is just 1. It's going to be A times 1. So therefore 90 is equal to, we're going to move the 20 to the other side. So it's going to be 70 is equal to A. So therefore A is equal to 70, which is B, double tick. Okay, for C, the coffee cools from 90 degrees to 50 degrees after 6 minutes. Find K. Okay, so what we are going to do here is we are going to set the temperature of the coffee, which is here, equal to 50, and then our Te is 20 and our A is 70, so we're just going to find K. Right, so was it 50? And we're going to substitute T as 6 because it has 6. It's equal to 50 is equal to 20 plus 70 A 70 is A, E to the minus, says minus 6k, and now we're going to transfer the 20 to the other side, so 30 is equal to 70 e to the minus 6k. Now we're going to use logs because we have our value e here, and we're going to do log e, and as always that term, 30 on 70 is equal to minus 6k. Actually, I prefer to write minus k6, and I'll show you why. So this can be simplified to just ln 3 over 7, which gives us ln 3 over 7. And now I want to get rid of the 6, so divide both sides by 6. So that's going to be on 6 is equal to minus k, and which can be simplified as 1 on 6 ln 3 on 7 is equal to minus k. And now to get rid of this negative sign, instead of making this one negative, we can actually flip the fraction around, because technically this is just 7 to the minus 1. So if we make it negative, it'll be 7 to the 3 minus 1, which is going to give us 1 on 6 ln 7 on 3 is equal to k. And hence we have our answer, double tick. K is equal to 1 on 6 ln 7 on 3. Now for part D, it says find how long correct to the nearest second will it take for the coffee to reach 30 degrees Celsius. So now we are finding T. So I'll just put our original equation. T is equal to T E plus A E minus K T. So we want 30 degrees Celsius. So we want T to be 30. It's equal to, we already know that TE is just 20, and A is 70. E to the minus K, we already know, is just minus 1 on 6 ln 7 on 3 from here. That's minus 1 on 6 ln 7 on 3 times by T. Now again, we're going to move this term to the other side, so minus 20 from both sides, so we get 10 is equal to 70 e to the minus 1 on 6 ln 7 on 3 times by T. So we get, so now we're going to actually move T to the front here, so we get minus T times by 1 on 6 ln 7 on 3, and then we're going to use logs again to find the power, what the value of this term here is. So we're going to do log e, which is this term here, 10 over 70, which is just 1 on 7, is equal to minus T times 1 on 6 ln 7 on 3. To find minus T, we're going to divide both sides by 1 on 6 ln 7 on 3, so we're going to divide that, so it's going to be log e 1 on 7 over 1 on 6 ln 7 on 3 is equal to minus T, and for T we are just going to we're just going to make this whole fraction negative, therefore T is equal to minus log e 1 on 7 1 on 6 ln 7 on 3, which is equal to 13 minutes and 48 seconds, I believe. Let me just double check in my calculator. 47 seconds actually. So 47 seconds is our final answer. Double tick.